So this whole unit is going to be over what we call functions. Raise your hand if you've heard of a function before. Some of us? Okay, cool. So a function is a relation in which each element of the domain is paired with exactly one element of the range. In basic terms, all that means is 1x to 1 y value. 1x to 1 y. Okay, put a little star right here. We also have what are called one-to-one functions. Okay, there's two criteria for that though. They have to have 1x to 1 y, just like a regular function, so they have to be a function. And then they also have to have 1y to 1x. Sorry, that didn't make it on the blanks there, but that is a one-to-one function, okay? So an example of this, and we might want to put this like over in the side notes here. So if I have an example, so for instance, if x is people, okay, and y is birthdays, that's going to be just kind of the visual I want you to think about when you think of functions, okay? So me, I'm one person, correct? Can I have more than one birthday? No, I cannot, okay? So therefore, I'm a function, okay? I'm one person. I can't have more than one birthday. That makes me a function, okay? So let's think about this whole class. We're all people, right? Different people, okay? None of us are the same person. We don't have any twins in here. What about birthdays, okay? Could some of us have the same birthday? Could we be born on the same day? We would still be a function, right? Okay, that's okay. But we can't have one person being born on 2 days. Does that make sense? Okay, so if we had any repeat birthdays in here, that would mean we're a function. But if we didn't, if all of us were born on different days, that would be a one-to-one function, okay? Meaning we had 1x to 1y and 1y to 1x. Does that make sense? You with me? Okay. So that's just kind of how I want you to think about these if you struggle. Displaying functions. Okay, so the first way that we can display functions is going to be through ordered pairs. Through ordered pairs. We can display ordered pairs just by writing parenthesis x, comma, y, close parenthesis, right? We could also put these in a table. Every row in a table is an ordered pair. The second way is going to be through mapping diagrams. You might have seen these before, maybe not. And then the last way is going to be by graph. By graph. Okay, so what I want you to do, I want you to look at example 1 there. Don't say it out loud, but just look at it and tell me, is that going to be a function or no? What do we think? How many of us think yes? Okay. Anybody not think it's a function? All right, we're golden. Yes, this is a function, okay? If we look at all of our x values, are any of those repeating? Meaning, do we have any duplicate people? No, we don't, okay? So yes, this would be a function. Would it be a one-to-one function? Do any of the y's repeat? No, so yeah, this would be a one-to-one function as well, okay? Now I want you to look at example 2. Tell me, is that going to be a function or not? No, why not? Yep, 3 is the same x value. It's got 2 different y values, okay? We cannot have that, so therefore that would not be a function. Any questions on that? Okay. Next way we can display these are actually the same exact coordinate points. So we already know the answers of the first one's going to be a function, the next one's not. But how we put these in a mapping diagram. So if we look, the first bubble is going to be our domains. That means the same thing as our x values. Okay? 2 things we got to remember when we make these mapping diagrams. The first one is that these numbers have to go in numerical order from least to greatest. Okay? And then the second one is if we have any repeat numbers in our x's or in our y's, we only have to write them one time, okay? So if I look at 9, 3, 1, and 10, I don't have any repeats, but I need to put those in order. So I'm going to do 1, 3, 9, and 10. Okay, and then the same thing with our y values. We got 3, 2, 4, and 18. Whoop. So if I write those in order, it should look like that. And then if anyone's seen these before, does anybody know what that last step is for constructing one of these? Yep, you gotta draw lines, okay? So match up the x's to their y's. So 9 is gonna go to 3, 3 is gonna go to 2, 1's gonna go to 4, and 10 to 18, and that's it. That's how we draw one of these. Okay, do we see how there's no x value that has 2 lines coming out of it? They all just have 1.
Yeah.
That means it's a function, right? Okay, if there were 2 lines or more coming out of the same x value, this would not be a function. Are we cool on that? Okay, go ahead and make the next one. Go ahead and make example 2. Construct that for me. What'd you put in the domain? 1, 3, 4? I like it. Only have to write the 3 one time. What about the range? 2, 4, 10? I don't see a 3. 4, 2, 10, and 4. You're close though. 2, 4, and 10. And then we just draw our lines, right? So 3 is going to 4, 4 to 2, 3 to 10, and 1 to 4. And we can see that there are 2 lines coming out of the 3, right? Which means that this is not a function. Okay. Any questions on that? Okay. Moving right along. Lastly, last way to display these is as a graph. I made all the other classes plot these points, but we're going to save a little time today. Just draw on example 1, draw a graph that just kind of looks like this. I trust that we know how to plot points, so we're going to save a little time today, okay? And then on that second graph, I want you to draw one that looks like this. Okay. Give me 1 second. So when we are looking at graphs, we have what is called the vertical line test, okay? So when I draw a vertical line through any point on the graph, if it only touches once, so one time, then yes, it's going to be a function, okay? But, however, if at any point on this graph, if I draw a vertical line anywhere on the graph and it touches more than once, then it's not going to be a function. Okay? So looking at the first one, if I draw a vertical line anywhere through that, is there anywhere where it's going to touch more than once? No. Doesn't matter where I draw it. I'm only going to touch one time. So therefore, is this a function? Yep, it is. Okay. What about this second one? I'm seeing some heads shaking. Why not? If I drew one over here, it would only hit once. Yeah, any point though. So if I drew it right there, aren't I hitting multiple values? Yes. Okay, so therefore this is a function or not? Not. It's not a function. Okay. Any questions on that? Cool. All right, so a little visual on how we use a function, how a function works, okay? So basically it's like a machine. Anything that's gonna go in has gotta come out, okay? And there's multiple words that we use for this, so just know that they're all synonymous. Input is gonna be the same thing as domain. And we said domain is also our x values, okay? That all means the same thing. Okay, and then we also have our output, which is going to correlate with the range. And it's also going to be our what? Yep, y values. If domain is x, range is going to be y. Okay? So that shouldn't be a new thing. We should have heard that before. Okay. Next thing. Again, this is a long day, guys. Promise we'll try to get through it the best we can. So this is what we call a piecewise function, all right? What word do you hear in the word piecewise? Wise, yeah, wise, and also piece, okay? Piece is going to be the more important one, though. Okay, so what a piecewise function is exactly what it sounds like. It's pieces of different functions put together, okay, on the same graph or in the same equation. So this is actually how a piecewise equation is written. You've probably seen this on an ACT before if you've taken the ACT, and you've probably been like, what the heck is that thing? Okay, because it looks really weird. So when you see something like this, the first thing I want you to look at is just count the rows here. How many rows we got? 2. That just means we have 2 pieces on this. Okay, there's only going to be 2 pieces on this graph. And then we want to look at the domains. So one thing I like to do is just kind of draw a line here to separate. These are my equations here, and these are where they exist, where their domains exist. Okay, so basically f of x is the same thing as y. Y equals negative x minus 4. We can graph that, right? We've graphed that before. That line is only going to exist on this graph where x is less than or equal to 5. Okay? It's not going to exist anywhere else. It's just going to be a piece of that line. Okay? Same thing with this guy. You've probably not graphed something like that before. We will graph that this year. That piece only exists when x is between 5 and 10 or equal to 10. Okay? So that's how we read these. So we will get into graphing these at a later point. But for today, we're just going to kind of plug in some values and see where they go. Okay, so for instance, the first one it's asking for is f of negative 2. So basically what that's saying is that when x is negative 2, okay, where's that going? So if I take that value and I put it right here, is negative 2 going to be less than or equal to 5, or is it going to be between 5 and 10? Yeah, less than or equal to 5. So I only need to plug that negative 2 in to the first piece. Don't plug it into both, okay? Just the piece that it goes in. And I plug it in for x, okay? So what I want to do here is I just want to take my negative 2, put it in for x. So negative, parenthesis, negative 2 minus 4. And then just simplify that. Okay? What is a negative 2? Positive 2, and then subtract 4 from that. Negative 2. Yep, that's my answer. That's it. Okay, I want you to go ahead and try f of 0. Just try that one for now. What is f of 0? So take that 0, go look at the domain, see which piece it's going to fit in, and then go plug it in. All right, what are we thinking, top or bottom? How many of us think it's going in the top piece? Okay, cool, you're right. It is going to go in the top. The reason for that is if I go plug in 0 for x, 0 is less than or equal to 5, right? It's not going to be between 5 and 10. So that is why it's the top piece. So when I plug that in, what do I end up getting? If I plug in 0 to this. Anybody? Negative 4, right? So negative 0 minus 4 is just going to be negative 4. That's it. That's my answer. Okay. Next up, we've got f of 5. Ooh, that's kind of tricky. Where do we think f of 5 is going to go? Top or bottom? Top, why top? Yeah, equal to 5. We got to pay attention to those equal to signs. So anytime we get a number that looks like it could go in either, okay, pay attention to what the equal to sign is, or if there is one. All right, so that's got to go in the top as well. So I'll plug that in. I end up with -5 minus 4, and what's that going to be? -9. All right, and then last but not least, f of 11. Ooh. Piece is that going to go in? It's not going to go in either, right? It's not defined. What do we say if something's not defined? What is it? Undefined. Good. So that would be undefined. Anytime that there's a value that does not exist in that domain, that just means it's undefined. It's not going to be on that graph. Okay. Any questions on that? Okay. The next thing I'm going to write down, you don't have to write down, but I just want to put a little hypothetical question in here, just because it might be on your homework and a couple people got confused. So let's say, for instance, I added one more piece to this where x was greater than 13, okay? And I made it the absolute value of x. Okay, now let's say that I asked you to find f of 20. Would that fit in that piece? 20 is bigger than 13, right? Okay, what is the absolute value of 20? What is it? 20. Good. Absolute values always make it positive. So even if I asked you for the absolute value of -20, it would still be 20. Okay, are we good on that? Cool. All right, we're going to keep going. Function operations and composition. Okay. These look kind of crazy too, don't they? We might have seen this on an ACT as well if we've taken it. These look way harder than they are, okay? The main thing we are focused on are these 4 things right here. Addition, subtraction, multiplication, and division. And we know how to spot those, don't we? Yeah, we learned that in elementary school. We know what signs mean addition, subtraction, multiplication, and division. That's what we're looking for here, okay? So anytime I see something that looks kind of crazy like this, h of x equals f plus g of x, I know I can break functions apart. If it's telling me to add, I just break those functions apart and I add them, okay? Same thing with subtraction. Break them apart and subtract them. Multiplication and division work the same way too, okay? So that's all we're doing here. So when we go practice this, we're going to try each of these operations. So up top, my example, so I'm saying f of x equals, 5x.
I found this on the web.
Oh, hi Siri. Okay. And then g of x equals x plus 2. So I'm giving you those, okay? And now we're just going to perform these operations. So if it tells me to do f plus g of x, I know that that's addition because I see a plus sign, all right? And I'm just going to go and add them. It's the same thing as f of x plus g of x. And I know what both those are because it just told me. So all I have to do is do 5x plus x plus 2. Can I add those together? Can I simplify that? What would it be? Yeah, combine like terms. 6x plus 2, that's my answer. That's it. 6x plus 2. Okay. Next thing we have subtraction, we got multiplication, and we have division. So I want you to go ahead and just try those, okay? But one thing before you get started, and these are 3 terms you're going to hear me say all throughout the year, so we really need to know what they mean. What's a monomial? Anybody know? Okay, it means singular, right? So singular term, if there's just one term, that's a monomial. So for instance, f of x here, that would be a monomial. That's just one term, 5x, okay? Then we have binomials. What do we think that's going to be? 2 terms being added or subtracted. So g of x is going to be a binomial. What would be a trinomial? 3, okay? And so on. It keeps going up. So anytime you have a binomial or bigger and you're subtracting or multiplying, you got to put it in parentheses. Okay? So that's your key right there. We just said g of x is a binomial, and we're subtracting and we're multiplying, so we gotta put that one in parentheses when we do that. Are we cool with that? Okay, go ahead and try those. Work with your table. Subtraction, how do we set that up?
5x negative sign, parentheses, x plus 2.
I love it. Good. 5x minus x plus 2. Since x plus 2 is a binomial, it's got to go in parentheses. Okay? Now do you see why? Do you see why that had to be in parentheses? Okay? Because if I didn't use parentheses, I would technically only be subtracting the x. Okay? And we have to subtract that whole thing, so that negative sign has to be distributed out. Okay? So when we do that, we just distribute it to everything inside the parentheses. We end up with 5x, then what? Minus x, minus 2. Okay, now we're subtracting the whole thing. And what's that going to give me? 4x minus 2. Cool. Okay. Multiplication. How are we going to set that up? F times G. Thank you. Perfect. 5x times x plus 2. Now what? Distribute. What is 5x times x? Yep, multiply the coefficients, add their exponents. 5x squared, and then 5x times 2? 10x. That is it. Any questions on that? No? You guys are so talkative today. And then last but not least, division. Oh no.
5x over x plus 2.
Yep, we're just dividing them. 5x over x plus 2. That's it. Can't simplify that. We got a monomial over a binomial, so don't even try. Okay. We all right? Some of us look really sad. Don't cry on me. I don't. Now, we got some examples here, okay? We are getting closer to being done. Got a little ways to go, though. Here's what I want you to do. I want you to work with your table. I want you to do f plus g of x, and I want you to do g minus f of x. So the first and third problems right here. So work with your group and figure out what those are. Notice on that third one, though, it's not f minus g, it's g minus f. Time to learn. All right, f plus g of x. Let's bring it back, guys. F plus g of x, what do we do? Good. 2x plus 4 plus 5x minus 20. We're just adding those two functions together. How do we simplify that? 7x minus 16. The 2x and 5x add together, and the 4 and negative 20 add together as well. Good. How many of us got that one? Sweet. Got some brainiacs in here. I like it. All right. Looking at these first two here. So the one we just did and the one underneath of it. What's different?
There's a 2.
There's a 2 instead of an x, right? Okay, so we're no longer finding f plus g of x. We're finding f plus g of 2. What was that? That's exactly what you do. Yep. So you take this answer here that we just found, and we are going to plug in that 2. Okay? So when we do that, we do 7 times 2 minus 16. What is 7 times 2? 14 minus 16, and we get negative 2. Okay. You want to see a magic trick? Are you ready? Okay. And everybody watch. You're gonna think this is so cool. Okay, so do you see how this is f plus g of 2? Okay, and do you remember when we did f plus g of x, we broke that into f of x plus g of x, right? So what you're saying then is I could break this into f of 2 plus g of 2. Anybody see where I'm going with this? Okay, so if I do that, all right, that means I can literally just go plug in 2 to f, then go plug in 2 for g, and then just add those two things together. Okay, so that is the other way we can do that. On some of these problems, that's going to be a faster way. On some of them, it's going to be slower. Okay, it's just going to depend, but I just want to show you this. So if I plug 2 in to f, it's 2 times 2 plus 4, which is 8. Okay, if I plug 2 in for g, it's 5 times 2 minus 20. 5 times 2 is 10, minus 20 is negative 10, and then I just add those two things together. So 8 plus negative 10 is negative 2. Is that the same thing as what I just got? Yeah. I'm sure it is. Okay? Do we all understand that?
Yes.
Yeah, we can break operations apart. It doesn't matter what operation it is. This will work for anything. Okay? This will work for subtraction, this will work for multiplication, and this will work for division. I'm going to show you how. G minus f of x. How do we set that up? You did this one. What's going first?
G
G. So 5x minus 20.
in parentheses.
Yeah. What operation sign am I using? In the middle. Subtraction, and then parentheses, that next binomial. 2x plus 4. How many of us set this up correctly? Please, please, please. All right, cool. If you didn't, please fix it. This tells me that I've got to do what here? Got parentheses. I got to distribute that out. So I end up with 5x minus 20 minus 2x minus 4. And when I add those like terms together, what am I going to get? You got it. 3x minus 24. Are we okay with that? Okay. What do we think we're going to do on that last one?
Plug in 2 or negative 2
Mm-hmm.
x.
Plug it into the answer.
Yeah.
Or I could find g of negative 2 and then subtract f of negative 2. That would work too. Yep. But this is easier right now.
If you
I'm gonna
did
plug in
that,
negative
would you
2.
solve inside the parentheses and then distribute?
So what?
If you
If you did it the other way, could you avoid parentheses?
could you solve inside the parentheses and then distribute?
Technically you would. Yeah, because you would do f of negative 2 before you subtracted. Okay? So 3 times negative 2 minus 24. What is that? Type that in your calculator if you can't do mental math today. Yeah, negative 6 minus 24, which is? Thank you. That's it. Okay. Fun stuff. All right, with your groups again. You are doing f times g of x, and then on that next page, the third one is f divided by g of x. Do those right now. Okay, f times g of x. Anybody think they set this up right? Anybody feeling confident? Emily Bell?
Oh, I don't want to say it out loud.
You don't want to say it out loud? You want me to come look at it? You sure did. Okay, so she set them both up, multiplying them together, but put them both in parentheses. That's the key here, guys. Both of them are binomials. Both of them have to go in parentheses. Okay. When we have two binomials being multiplied together in parentheses, this starts with an F, this process of how to solve that. What's it called? Starts with an F. Foil. Yep, we gotta foil these out. How many of us have seen foiling? Has anyone not seen it? No one in my first hour had seen it, but I think they were lying to me. Okay, I think everybody has seen it. You should have at least. Okay, so what we want to do here, it is first term times the first term. So x squared times x. X cubed, good. When you're multiplying variables, you add their exponents, good. Then it is going to be first term times the second term, x squared times 1. Just x squared. Okay. Then we do second term times first term. Negative 1 times x is negative x. And then finally, second term times second term. Negative 1. Negative 1 times 1 is negative 1. Any of those like terms? No, that's it. That's my answer. Any questions on that? No? Moving on? Okay. What I would do. Okay. So, if we have f times g of 4, what do you think we're doing there? You don't know? Yeah, aren't we going to plug that into our previous answer? Or we could find f of 4 and g of 4 and just multiply those two things together. Yeah. So we got 4 to the third plus 4 squared minus 4 minus 1. And I know the answer, but do you? Type it into your calculator. If you don't know how to type in exponents bigger than 2, use that caret button. Looks like this. What are we gonna get? What did we say? 75? Cool. All right. Last but not least, we have f divided by g of x. How'd you set that guy up? Did you? How would you? If we're just dividing the two. You don't know? We just set it up as a fraction, right? Can't we just put the numerator over the denominator? Which one goes on the top? F of x. What is f of x?
X squared minus 1.
Okay, what goes on bottom?
X plus 1.
Okay. Anybody know how to factor x squared minus 1? No? Did we factor in Algebra 1?
That was 2 years ago.
That was 2 years ago? You act like that was so long. It was? Does it feel like forever? Okay. If we're factoring x squared minus 1, that actually follows what we call a difference of squares pattern. Don't worry if you don't remember this. We will come back to it. It will be a whole unit, and it will be so fun. But that's how you factor x squared minus 1. You can't factor the bottom, but if you notice, there's two binomials that match up, and because we're fully factored, we can cancel those two things, leaving us with just x minus 1 as our answer. If that's foreign language to you, that's okay. Okay, because we're coming back to it. It's going to be so fun. You can't wait, I can tell. So last but not least, f divided by g of 1, that should be pretty darn easy. Yeah, can we do that? No? We can't do this problem right here?
1 minus 1 is 0.
No way. No way. You guys are so smart. Okay, cool. Any questions on that? We are getting close to being done. We have 2 things left, 2 big things, okay? This is the first one. And if you look at that, does that make your brain hurt a little bit? Tiny bit? Okay, let me kind of reword this in a better way. So, what number can I not divide anything by, or my calculator is going to give me an error? What can I not divide by?
0.
0, okay? Type anything into your calculator and divide it by 0, it's going to tell you error, okay? That is because it is undefined. So anytime you have a fraction, okay, and that denominator equals 0, that means it's going to be undefined for that value, okay? So I'm going to make this a little bit easier on us. I don't really like those things. My brain's starting to hurt too. We're going to make this a little simpler. F of x is going to be x, and g of x is going to be x minus 2. Now I want you to set this up, f divided by g of x, with those two functions. Is that easier? Yeah. Okay, set it up. F divided by g. What we got? X over x minus 2, okay? That's what we call a rational, or a fraction, okay? That'll be a whole nother unit that we deal with later, okay? But one thing we've got to be careful with is if I take that denominator and I set that equal to 0, so the denominator is just x minus 2, I'm setting that equal to 0. What does x equal if I solve that? X equals 2, okay? Actually, x can't equal 2. See that little notation there? The equal sign with the cross through it. Has anybody seen that? Yeah? Okay. That means x can't be 2. Reason being, if I go plug that back in for my denominator, isn't 2 minus 2 0? Yeah, and we can't have that. Can't have a 0 in the denominator. Does that make sense? That will work for any rational. If you set the bottom equal to 0, whatever that number is, that's what makes it undefined. Are we cool on that? Okay, last big thing. Last big thing. Composite functions. Fun stuff here. Okay, what a composite function is. It is a function of a function. A function of a function. Okay, two ways we write this. The first way, you're going to see it a lot, but I don't like the way it's written, okay? And that is when we see one function, so we'll call it g. We have a little o, which stands for the word of, okay? And then we have our next function. So in this case, we'll use f. So g of f of x. That's how you would say that. Golf. Okay. Which one of those letters is written first? G. So it's going to go on the outside. It's going to go first. Okay. After the of, what letter do I have? F of x. So that's going in the middle, f of x. And I'm actually going to make that another color just so we can kind of like see this better. Okay, do we see how that f of x is inside of the g? Yeah. Okay, that's what a composite function is. It means that there's a function inside of a function. Okay? We always work from the inside out. So the inside we evaluate first. Okay, so in this case, f of x is going to go first. We're going to evaluate that. And then we use that number to evaluate the outside. Sounds more complicated than it is. We're going to practice this. Does everybody have that written down? Yeah?
Yeah.
Are we golden? Okay. Here we go. Number 1. G of f of negative 5. Okay? I'm going to write that in the better notation. So G comes first, right? What's going on the inside? F of, not x, negative 5, good. Yep, we're using a number. Yeah. And we said we work from the inside out, so meaning I need to find f of negative 5 first. Do we know how to do that? Duh. We plug it in, right? Yeah. Plug it into f. So what am I writing? Negative 5 minus 2, which is... Okay, so you just told me that f of negative 5 is negative 7, right? Yeah, okay, so watch this. I'm just going to change that f of negative 5, and now I'm just finding g of negative 7. Because I just found what f of negative 5 was. I'm just replacing it. So now what?
49.
Yeah, just plug it into g. So negative 7 squared is 49. Good. Questions on that? Do the next one. We'll have one more talking point on this, and then we're going to call it a day. So try the next one right now. I'm coming around. Write that in the better notation. Tell me how to do that. What's on the outside? F. What's on the inside?
G.
G of what? Thank you. You guys are so smart. What are we going to evaluate first? G of negative 5. How do I do that? What is it? What am I going to do with that 25? And 25 minus 2 is 23. I like it. Good. Great job. Okay, we're almost done. I just got to talk through one more thing. Are we all listening? Give me like 1 minute of your time. Okay, so on the homework, you're going to see that there are going to be some questions that look just like this, but instead of a number, it's x, okay? Or it's 1 minus x, or it's some type of something with a variable. It still is going to work the same way, okay? So for instance, on this one, you don't have to write it down, but just make sure you remember. And if you won't remember, you might want to write it down, okay? If I had f of g of x for this equation, okay? Still going to write it in that better notation, okay? So f is going to be on the outside. Instead of g of a number, we're going to have g of x on the inside, right? Okay, so I'm still going to solve this the same way. What is g of x, though? It's just x squared. I don't have to plug anything in, right? I would just leave that alone. Okay, so this is now the same thing as just f of x squared. Well, now what am I going to do with there? If I'm plugging x squared in for f. Am I just replacing that x with x squared instead? Yeah, not doing any kind of crazy multiplying or changing stuff around. We're just going to have that as our answer. Yeah. Okay. Are we cool with that? I know today was long. I'm sorry. Promise next time it won't be this long. Are we cool? No one's mad at me? All right. Welcome to Algebra 2, Day 1. We are done.